Hello friends, and welcome to this 8th video of the series called Shortcuts and Alternate Methods. In this video, we are going to take one an extremely important chapter that is called Numbers. Numbers is one chapter that is common to all entrance exams, and the number of questions which are asked from this chapter is very high. Sometimes the questions are very easy, sometimes they are little difficult. So this exercise I have tried to cover almost all types of questions that can be asked from this chapter. Okay, let's start with the exercise. Let's start with the first question. It says find the units digit of the following. This is a product 3847 into 252 into 873 into 648. Now when we have to find the unit digit of a product, just consider only unit digits. So in the first number it is 7, second number it is 2, third number it is 3, and the last number it is 8. So we have to multiply 7 into 2 into 3 into 8. 7 into 2 is 14, so just take only the unit digit of that number, that is 4. 3 into 8 is 24, so take only 4. Now 4 into 4 is 16, so the last digit will be 6. Look at the options, second option is the correct answer. Okay, now the second one, this is a situation of powers. 3 raised to 68 into 4 raised to 73 into 15 raised to 101. Now see, any number ending in 5, whatever power you take, unit digit will always remain 5. For 4, you just have to look at odd powers and even powers. 4 raised to the power odd number, the unit digit will always be 4. 4 raised to the power even number, unit digit will always be 6. So 4 raised to 73, 73 is odd number. So unit digit of this number is going to be only 4. And 3 raised to 68. Now for 2, 3, 7 and 8, the powers repeat or the unit digits repeat after every 4 powers, and that is called cyclicity. You must check the theory lectures for this. So cyclicity for all of this is 4. That means divide the power by 4. Now 68 is divisible by 4. So 3 raised to 68 will have the same unit digit as 3 raised to the power 4. Alright, which is 81. So 1. The unit digit of 3 raised to 68 is 1. Unit digit of 4 raised to 73 is 4. Unit digit of 15 raised to 101 is 5. So the whole overall unit digit will be 1 into 4 into 5, and that is 20. So 0. So unit digit of this number is 0, and that is 3. Now, instead of doing all this, just you can see that this is a number that is a multiple of 5. This is a number 4 raised to 73, that is an even number. So whatever is this 3 raised to 68, it does not matter. Any even number into any number ending in 5 has to end in 0. So you can directly say the answer is third option. Alright, but just to make it clear, I have solved entirely. Now the next question. 8 raised to 29, 6 raised to 77. Now let's see. 6 raised to 77, unit digit is always 6. Now the powers, in the powers of 0, 1 and 8, unit digits don't change. 0, 1, 8 and 6. Sorry. In the powers of 0, 1 and 6 and 5 also, unit digit does not change. Right. So 6 raised to 77, unit digit is going to be 6 only. 8 raised to 29, cyclicity is 4. For 8, cyclicity is 4. So 29 divided by 4, remainder is 1. So 8 raised to 29, unit digit is going to be same as 8 raised to 1, and which is 8. So the first number unit digit is 8, then the second part of the first number is 6. So 8 into 6 is 48. So unit digit of this entire thing is 8 only. Okay. Then 342 unit digit is 2, 873 unit digit is 3, 2 raised to 68. 68 is a multiple of 4. So 2 raised to 68, unit digit will be same as 2 raised to 4. See, whenever the power is divisible by 4, you take the power 4 only. So 2 raised to 4 is 16. So 6. So unit digit of this product will be 2 into 3 into 6. Now 2 into 3 is 6, 6 into 6 is 36. So unit digit of this entire product is going to be 6. Now we have to take this 8 plus this 6. So 8 plus 6 is 14. So 4 will be the unit digit of this entire product. So 4 will be the answer of the question, that is first option. Okay, let's go to the next question now. Next question says, which of the following numbers is divisible by 3, 4, 7, 9 and 11? Right? Now divisible by all of them, that means LCM. First of all, LCM. LCM is the lowest number which is common multiple. Lowest number which is divisible by all of them. So either LCM or a multiple of LCM. So let's look at this 3, 4, 7, 9, 11. What will be the LCM? If 9 is there, then we don't need to consider 3. All the numbers are co-prime numbers. There is nothing common between them. So their LCM will be straight away the product 4 into 7 into 9 into 11. Now 4 into 7 is 28. 9 into 11 is 99. So if you multiply, it becomes 99 is 100 minus 1. So 2800 minus 28, and that is 2772. So 2772 is the smallest number that is divisible by all of them. Now any multiple of 2772 will also be divisible by it. So if you look at this option, 1463 is smaller than that, so that cannot be the answer. 10773 is odd number, so that cannot be the answer. Okay, 2772, double will be 5544. All right, so 4788 cannot be the answer because it cannot be a multiple of 2772. Now there are two options left, 5268 and 11704. So one way of doing this question would be just check whether all of them are divisible by, or whether the number is divisible by all of these things. Let's check one by one. So what about 9? First let's check 9. So last number, 1 plus 1, 2 plus 7, 9 plus 4, 13. 13 is not divisible by 9. So 11704 also cannot be the answer. So we are left with only one option, and that is 52668. That is the correct one. Or you could have checked all the options by 9 or 4 or 11. Right? So in any case, the answer is only B option. Second option is the correct answer. Okay. Let's go to the next question now. Next question says, what is the least whole number that should be added to the following numbers to make the multiple of 9? Now for 9, what is the divisibility test? The divisibility test is sum of digits. The sum of digits should be divisible by 9. Let's look at the first number, 3, 4, 5, 8, 2, 1. So if you simply add the digits, 3 plus 4, 5 plus 5, 10, plus 7 plus 5, 12, plus 8, 20, plus 2, 22, plus 1, 23. Add it again, 3 plus 4, 7 plus 5, 12, plus 8, 20, plus 2, 22, plus 1, 23. 23 is not divisible by 9. Now what should I add to 23 to make it divisible by 9? The nearest multiple of 9 to 23 is 27. So if you add 4, it becomes 27. Right? So 4 has to be added to this number. Answer is second option. Okay. Let's look at the second question. B, 6482. 6 plus 4 is 10 plus 8, 18 plus 2, 20. Now what should I add to 20 to make it divisible by 9? The nearest number would be 7. So the answer is 7, third option. Just add the digits and see how much deficit to the next multiple of 9 it has. Also, while adding, if the number is very large, what you can do is you can eliminate 9s. Or if there are two digits which add up to 9, you can leave them. For example, in this one, 8 plus 1 is 9. So leave it. 9 itself, leave it. 2 plus 7, leave it. 3 plus 6, 9. So that also you should leave it. What are you left with? You are left with 8 plus 4, that is 12. Now what should we add to 12 to make it divisible by 9? That nearest multiple is 18. So add 6. So the answer would be third option, that is 6. Now just to ensure that you have understood, add all the digits also. So 1 plus 9, 10 plus 8, 18 plus 2, 20 plus 8, 28 plus 3, 31 plus 7, 38 plus 4, 42 plus 6, 48. What should we add to 48 to make it divisible by 9? Obviously 6, so that it becomes 54, and that is divisible by 9. Alright, let's take up the next one. It is 2 plus 0 plus 0 plus 0 plus 3. So 5 plus 2, 7 plus 2, 9. It's already 9, already divisible by 9, so nothing to be added, 0. So answer is third option. Next one, 4 plus 2, 6 plus 3, 9. So remove it. Then 1 plus 4 is 5. Now what should we add to 5? We should add 4 to make it divisible by 9. So option fourth one is the correct answer. Okay, let's take up the next one now. Now this says, what is the least natural number that should be added to the following numbers to make the multiples of 11? Now 11 rule is add the odd digits and add the even place digits, odd place digits and even place digits, and take the difference. If the difference is divisible by 11, the number will be divisible by 11. First let's check what is the, so for 11 what we should do is, let's look at this. It is 2 plus 1, 3, and plus 0 is 3, and then 4 plus 3, 7 plus 2, 9. So 3 minus 9, that is minus 6. It is not divisible by 11. So let's do one thing. Let's add the options. Now, whenever you get such situation, say for example, you've got minus 6. So the answer will be either 6 or 11 minus 6, that is 5. Just try and understand that. Okay. So if the option, if there are two options, so clearly 4 and 7 cannot be the answer. It will be either 6 or 5. If there is a confusion, add 6 to this number. If you add 6 to this number, it will become 2, 4, 1, 3, 0, 8. And then apply the method again. So 2 plus 1, 3. So 3. 4 plus 3, 7 plus 8, 15. Now 3 minus 15 is minus 12. So this is not divisible. So clearly 5 has to be the answer. Right? If I add 5, what will happen? If I add 5, I will get 2, 4, 1, 2, 4, 1, 3, 0, 7. So 2 plus 1, 3 plus 0, 3. And 4 plus 3, 7 plus 7, 14. 3 minus 14 is minus 11. So clearly this is divisible by 11. Right? So 5 is the answer. Let's check in the second one. First add the odd place digits. So 5 plus 7, 12 plus 2, 14 plus 0, 14. 6 plus 8, 14 plus 4, 18. So 14 minus 18, that is minus 4. That means answer will be either 4 or 11 minus 4, that is 7. Okay, so look at the options. 2 cannot be the answer, 9 cannot be the answer. Now 7 and 4 both are there. See, if there was only one of them, the answer would be directly on that one of them. But here we have both 7 and 4. So what should we do? Add 7. Let's see what happens. If I add 7 to this, it becomes 5, 6, 7, 8, 2, 4, 7. Then the sum of odd place digits will be 5 plus 7, 12 plus 2, 14 plus 7, 21. And or even place would be 6 plus 8, 14 plus 4, 18. 21 minus 18 is 3, not divisible. So 7 cannot be the answer. 4 has to be the answer. Okay. If I add 4, what will happen? If I add 4, the digits will be 5, 6, 7, 8, 2, 4, 4. And then if you add 5 plus 7, 12 plus 2, 14 plus 4, 18. And then 6 plus 8, 14 plus 4, 18. So 18 minus 8 is 0. 0 means the number is divisible by 11. So 4 is the answer. Okay. The next one. 787878. Just by looks of this number, this should be divisible by 11. Let's see. 7 plus 7 plus 7. No, it is not divisible. So it is 21. 8 plus 8 plus 8, that is 24. 21 minus 24 is 3. So the answer will be minus 3. So answer will be either 3 or 8. 11 minus 3, 8. Okay. Let's look at the options. So 1 cannot be the answer. 10 cannot be the answer. It will be either 8 or 3. If I simply add 8 to this number, what happens? 7, 8 plus 7, 8, 7, 8 plus 8. So if I add 8, I will get 7, 8, 7, 8, 8, 6. Right? Now check this. 7 plus 7 plus 8. 14 plus 8, 22. 8 plus 8 plus 6. 16 plus 6, 22. Perfect. So 0. That means by adding 8, it will become divisible by 11. Okay. Now the next one. 1024, 105. So add the odd place digits. 1 plus 2 plus 1 plus 5. So 1 plus 2 is 3 plus 1, 4 plus 5, 9. And 0 plus 4 plus 0. That is 0 plus 4 plus 0 is 4. So 9 minus 4 is 5. So the answer will be either 5 or 11 minus 5, 6. So look at the options. 7 is wrong, 4 is wrong. It will be either 5 or 6. Let's add 5 to this. If you add 5 to this, you will get 1024, 110. Check this. So 1 plus 2 plus 1 plus 0. So it is 1, 3 and 1, 4. And 0 plus 4 plus 1, that is 5. 4 minus 5 is minus 1. So not divisible. So 5 cannot be the answer. So 6 has to be the correct answer. Alright. If I add 6, what will happen? 1024, 111. Right. So 1 plus 2 plus 1 plus 1. So 1 plus 2 is 3 plus 1, 4 plus 1, 5. And 0 plus 4 plus 1, that is also 5. 5 minus 5 is 0. So it is divisible. That means 6 is required to be added. Okay. Let's take up the last one. 4, 3, 4, 3, 4, 3. This seems to be same as C. Add the digit 4 plus 4 plus 4, that is 12. And 3 plus 3 plus 3, that is 9. So 12 minus 9 is 3. Alright. So the answer will be either 3 or 8. Okay. So 4 and 7 cannot be the answer. If I add 3 to this, what will happen? 4, 3, 4, 3, 4, 6. So 4 plus 4 plus 4, that is 12. 3 plus 3 plus 6, that is 12. So 12 minus 12, that is 0. So it is divisible. So 3 has to be added. Right. So that's the answer of this question. Let's take up the next question now. Now this question says, express the following numbers as a product of prime factors. So this is basically a question of factorization. Right. Now, here it's very important, if you remember the squares or cubes or tables, the questions will become really simple. 9261, straight away it is 21 cube. Now 21 is 3 into 7, so it is 3 cube into 7 cube. Right? Otherwise, see, if any other method to solve this question is going to take a very long time. Right? So look at the options, it is fourth option. What is the other method? Let's see. If I have 9261, clearly just by looking at it, you can say it is divisible by 9. So 9 plus 2 plus 6 plus 1, that is 18. Okay, so it is divisible by 9. So divide by 9, you will get 1, then 0, then 26, 2 times and 9. So 1029. Then 1029 is still divisible by 3. So if you take out 3 from 1029, it will give us 343. Wow. So now 343 is 7 cube, that you must know. So 9 into 3 is 3 cube and 7 cube. This is how we can factorize it. But it's better if you remember the tables or squares or cubes, at least as much as possible. For example, the second one, it says 3872. Now here it is not directly visible, right? But look at the options. 2 and 11, 2 and 11, 2 and 11 are there in all the options. So clearly it has to be resolved by 11. Okay. So 3872, first of all, you take, if you divide by 11. So what do you get? If you divide by 11, it will become 3 times 57, 5 times 22, 2 times. Now 352, Again, it is divisible by 11. So take out 11, you'll see that it comes out to be 3 and 2. Perfect. So what do you get? 11 two times, and 32 is 2 raised to 5. Look at the options. 2 raised to 5, 11 square. Third option is the correct one. Right? Similarly, 1144. You don't even need to look at the options because 1144 is clearly divisible by 11. Right? So it becomes 11, if you divide, it becomes 104. Now 104 is divisible by 4. So it is 11 into 4. In fact, it is divisible by 13 into 8. So 11 into 13 into 2 cube. So if you remember the tables very well, it will be really easy. So look at the options. 8 is 2 cube. So 2 cube into 11 into 13, that is first option. Okay. 3, 8, 8, 8. Look at the options. 2, 3, 2, 3, 2, 3 and 2, 3. So here you will have to follow the process. So let me do it here. 3, 8, 8, 8. Right. So if you look at, if you add the digits, 3 plus 8 plus 8, 27, right? So it is divisible by 9. So divide by 9. So 9 4s are 36. 28, 3 times 27, 18, 2. So 432. And I think 432 is divisible by 8 also. 437, 9 also. So divide by 9 again. So divide 432 by 9. You will get 9 4s are 36. Right? 72, 8, 48. Perfect. Now 48 divide by 3, you get 16. So 3 square and 3. So 3 raised to 5. And 16 itself is 2 raised to the power 4. So look at the options. 3 raised to 5, 2 raised to 4. That is fourth option is the correct one. Okay. Now the last one. 7168. Right? This, if you look at the options, it can be divisible by 7 as well as 11. So first let's check whether it is divisible by 11 or not. So 7 plus 6, 13, A, 1 plus 8, 9. Not divisible. So first option cannot be the answer. All the other options we have 7. So divide by 7. Alright, so 7168 can be written as 7 into, divide by 7, it will become 1024. Perfect. So it is simply 2 raised to 10. Right, so 7 into 2 raised to 10, that is fourth option. Okay, let's take up the next question now. Now this one says simplify the following, and it's a question on BODMAS rule. So BODMAS, if you know, it is bracket of division, multiplication, addition and subtraction. This is the order of operations. So 77 into 335, 37 into 665 minus 40 into 335. Now here you have to be a little careful because this is a little difficult calculation. So let's do one thing. First one and the third one. Let's take out 335 common. If you take 335 common, you will get 77 minus 40 and plus it is 37 into 665. Now see, 77 minus 40 is 37. So 37 and 37 are common. So take 37 out and inside you will have 335 plus 665. Now which is 1000. So 37 in 37 into 1000, that is 37,000. Fourth option is the correct one. Right? You have to be a little careful here. Now B. Question number B. Here it says 2 7 by 12, 3 1 by 4, 1 1 by 2, 2 1 by 6 and 2 1 by 3. So what we should do? Add the integer part. So 2 plus 3 minus 1 plus 2 minus 2. So integer parts together and fraction part separate. So 7 by 12. Okay. 7 by 12 from the first one. Second one it will be plus 1 by 4. Third one will be minus 1 by 2. Fourth one plus 1 by 6. And last one minus 1 by 3. So here 2 and 2 are cancelled. 2 plus 3, 5 minus 1, that is 4. So every option has 4 as the integer part. Okay. So we have to simplify this fraction part. Take LCM of 12, 4, 2, 6, 3, that is 12. 12 ones are so 7, 4 3s are so 3, minus 2 6s are, plus 6 2s are, minus 3 4s are. So we have 6 and 4 10, 7 and 3 10. So 7 and 3, 6 and 4 are cancelled. We are left with 2 by 12, that is 1 by 6. So answer is 4 plus 1 by 6 and that is second option. Okay. Now the third one. The third one is, look at this carefully, it is 3.13 square plus 4.25 square plus 2.62 square plus 6.26 into 4.25. Look at this, it is 6.26 is 2 into 3.13 into 4.25. Similarly, 8.5 into 2.62, this 8.5 is actually 4.25 into 2. So it is 2 into 4.25 into 2.62. Similarly, 5.24 into 3.13, that is actually 2 into 2.62. So 2 into 2.62 into 3.13. Very nice. Now, if you know there's a rule which says A plus B plus C whole square, it comes out to be A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Right? If you see 3.13 if you take as A, 4.25 as B and 2.62 as C, this whole thing actually becomes a plus b plus c whole square, because it is 2 into ab plus 2 into bc plus 2 into ca. So this is eventually equal to, this question can be equal to a plus b plus c. In place of a 3.13, in place of b 4.25, and in place of c 2.62 whole square, right? So if you add 25 plus 13, 38 plus 62, 100. So 2 plus 1, 3 and 4, 7 and 3, 10. So it is 10 square, which is equal to 100. So if you know this formula, this question becomes really easy. Second option is the correct one. Okay, let's take up the next question now. Next question says, find the square root of the following numbers. Now this is very interesting, really interesting, right? First one is 17689. There is a method of this bar method, and we do some division method. This is not required here, right? Listen to me very carefully. I'll explain certain things. 143, the nearest simplest number is 140. 140 square is 19600. So 143 cannot be the answer, because 140, this 19600 is higher than 17689, right? 47 is very low, even 50 square is 2500, so that also cannot be the answer. So we are left with 137 and 133. There is a number, simple number in between them, that is 135. Now numbers ending in 5, calculation of square is very easy. How? In the end we will have 25, and in the first part we have 13 here. So multiply 13 to the next number, that is 14. 13 into 14 is 182. So we know that 135 square is 18225. Alright? 135 square is one. I'll just explain. If there is a number ending in 5, then the square of that number is calculated like this. First part x into x plus 1, and second part 25. So here it was 13. 13 into 14 is 182, and 5 for 5 we have 25. Now 18225 is more than 17689. So our answer has to be less than 135. So third option is the correct one. Alright? Okay. Now there is another way to look at it. Instead of this, the other way, how do we go about other way? We can find the last two digits of square of any number. Say for example, if I have to check 37 and 33, look at 37. Don't worry about 1 here. Look at only 37. What is the difference from nearest 50? Difference is 13. What is 13 square? 169. So in the square of 137, there will be 69 in the end. What about 33? 33's nearest 50 difference is 17. 17 square is 289. So square of 133 will have 89. Right? Here we have 89, so 133 has to be the answer. Alright, let's take up the next one. 2601. Right? Now 2601, if you look at the options from 63, from 50, the difference is 13. 30 square is 169. See, in the end, it should have 69. Here it is 01, so 63 cannot be the answer. 59, nearest 50 difference is 9. 9 square is 81. So square of 59, in the end, we must have 81. So 59 also cannot be the answer, because we have 01. Okay. Now 61, difference from 50 is 11. 11 square is 121. So in this square of 61, we should have 21 in the end. So 61 also cannot be the answer. 51, difference from 51. 1 square is 1, that is 01. So 51 will be the answer of this question. Alright, so this is how you can do these questions. Let's take up the next one. So 136.89. Don't worry about point, because the options also have 1 point or 1 digit after point. Look at 89. Now here, look at the last two digits, 07. So square will have, we need only the difference from either 50 or 100 also. So last two digits 07, that means difference from 100 is 7. 7 square is 49. Here it is 89. So 107 is wrong. 113, 13 square is 69. 169, so this cannot be the answer, because we have 89 here. 103 square is 909, cannot be the answer. 117, 17 square is 289. So 89 in the end. Yes, this is the only option. So 117 is the correct answer for this question. Okay. 25921. Look at the option. 61. Nearest 50. Difference is 11. 11 square is 121. So 21. Here we have 21. Oh, so 161 can be the answer. Let's see. 69. Difference is 19. 19 square is 61. 361. So this cannot be the answer. 67. Difference is 17. 17 square is 89. So this cannot be the answer. 59. Nearest 50. Difference is 9. Square is 81. So this cannot be the answer. Clearly 161 is the answer. Alright. Next one. 54756. Look at the options. 216. Last two digits 16. You take either the last two digits or the difference from nearest 50. That means difference from nearest 50 or difference from nearest 100 also. So 16 square is 256. So 56. Oh, so 216 can be the answer. Let's look at 24. Difference is 24 square is 76. So this cannot be the answer. 34. Difference is 16 square is 256. Oh, right. So this can be the answer. Right. So we have two options now. 36. Difference from nearest 50 is 100. 14. 14 square is 96. 196 to 96. So this cannot be the answer. So it will be either 234 or 216. right? Take any middle number, any number in between. Let's say 216 and 234. In a number in between, simplest number is 220. 220 square will be 22 square is 484. So 0 0. Now here our number is 54756, which is more than 48400. So square root will be more than 220, hence 234. Right? So 234, third option is the correct answer. Okay, let's go to the next question now. Eighth one. A number when divided by 323 leaves a remainder of 61. Find the remainder when the same number is divided by 19. Now for such questions, for these remainder questions, you need to know this rule that any number when divided by a divisor, we can write this number as equal to n into d into q plus r, where d is the divisor, q is the quotient, r is the remainder. So here our number when divided by 323, there is some quotient we don't know and the remainder is 61. Now the same number n should be divided by 19. So what will happen? If I take n by 19, this whole thing will get divided by 19. Now look at this closely. 323, if you divide by 19, it is actually 19 into 17, right? So 323 is divisible by 19, so no remainder from here. If there is any remainder, it will come only from 61. So 61 divided by 19, if you divide, remainder is 3. No, not 3, it is 19, 3s are 57, remainder is 4, right? So look at the options, 4, second option is the correct one. Just remember this rule, a number equal to divisor into quotient plus remainder. Now let's go to the next question. Ninth one, find the LCM and HCF of the following numbers or fractions. First question, 36, 90, 48. So what should we do? Let's take 6 common. If we take 6 common, then let with 6, 15 and 8. Now from 6, 15 and 8, 6, 15 and 8, you can take 3 common. 3 will become common from 6 and 15. So you will be left with 2 and 5 and 8 as it is. Then you take 2 common, you will be left with 1, 5 and 4. So multiply 6, 3, 2, 6 and 1, 5, 4. So it is 6 into 3 into 2 into 1 into 5 into 4. Right? So LCM would be 6 into 3 into 6, that is 36 into 5, 180 into 4, 720. Oh, there is only one option. What about HCF? HCF is something that is common to all the three. That is 6. So HCF is 6, LCM is 720. Alright. Let's look at the next one. 38, 152, 228. Clearly I can see that 19 is a factor of all of them because I remember the table of 19. You must do that also. So if you take out 19, 38 will give us 2, 158 will give us 8 and 228 will give us 12. So further you have 2 common. If you take 2 common, you will get 2 common from 2, 8 and 12. You will get 1, 4 and 6. Right. So the entire number common to everything is 19 into 2. So HCF will be equal to 19 into 2, that is 38. Right. So that means first option cannot be the answer, third option cannot be the answer, second and fourth can be the answer. What about HCF? For HCF you take further common 2 here, so you will get 1, 2 and 3. So the HCF would be 19 into 2, 38 into 2, 76 into 2, 152 into 3, that is 456. So fourth option is the correct one. Right, so just be a little careful here. Now C. To find LCM, how do we go about it? Take all the common items once. So all the common items 2, 3, 5, 11, perfect. Then take the higher power for all of them. And take in fact all the prime factors, right? Common item only once and all the others also. Here everything is common. And take the higher power. So 2 cube, 2 square, so 2 cube. Here we have 3 square, here we have 3, so 3 square. Here we have 5 raised to 1, so 5 and 5 raised to 2, so 5 raised to 2. Here we have 11 raised to 1 and 11 square, so it is 11 raised to 2. So the answer will be 2 cube into 3 square into 5 square into 11 square. Now, this is a very tricky situation. 3 square is 9, 11 square is 121, so it is 121 into 9. We have to multiply that, okay? So 121 into 9, 1089, okay? 1089. Then 2 cube is 8 into 5, 40 into 5, that is 200. So 200 into 1089, if you multiply carefully, it will come out to be 9 2s is 18, 8 2s 16 and 1 17 and 10 2s 21. So 217800. So the LCM is 217800. Oh, there is only one option, so that has to be the correct one. What about HCF? Let's calculate HCF here. So HCF of these two numbers will be taken as only the common prime factor. So 2, 3, 5, 11, 2, 3, 5, 11. So 2, 3, 5, 11 and that too only the lower powers. So lower powers 2 cube and 2 square. So lower power will be 2 square. Right? 3 square and 3 raised to 1. Lower power will be 1. 5 and 5 is square. So lower power will be 1. 11 and 11 square, lower power will be 1. So 4 into 5 is 20, 20 into 33. So it is 660, right? That is the correct answer. Okay. Now comes the next one. 5 by 7, 10 by 9, 15 by 14. All of them are simplified form? Yes. So what about LCM? LCM will be equal to LCM of numerators divided by HCF of denominators. Now LCM of numerator here, LCM of 5, 10 and 15 would be 30. And HCF of 7, 9 and 14. HCF of 7, 9 and 14. Correct. So it has to be 1. Okay. So LCM will be 30. Right? Look at the options. There is only one option. So that has to be the correct one. But anyways, I'll explain HCF also. HCF of fractions is HCF of numerators divided by LCM of denominators. Okay. So HCF of numerators will be 5, 10 and 15. HCF will be 5. Right? And LCM of denominator 7, 9, 14. So 14 nines are, because 7 is already a factor of 14. So 14 nines is 126. So 5 upon 126, that is fourth option is the correct one. Alright. Let's take up the next question now. 2 by 3, 4 by 9, 8 by 15. So LCM will be LCM of numerator, that is 2, 4, 8. LCM will be 8. And HCF of denominator, that is 3, 9, 15. So HCF will be 3, 9, 15. HCF will be 3. And similarly HCF will be HCF of numerator, that is 2, 4, 8. So it is 2. And LCM of denominator, that is 3, 9, 15 is 45. So 8 by 3 and 2 by 45. Look at the options. 8 by 3, 2 by, right. So second option is the correct one. Okay. Let's go to the next question now. Oh wow. This is a question of recurring decimals. So it is 0.666. First we need to simplify this. And how do we go about it? Let's see. This can be written as 0.6 bar. Now whenever this is a situation, look at this situation here, it is everything is after decimal, right, and everything is under bar, right. This bar represents the repetitiveness of this number. What you need to do is simply take entire number in numerator without bar, without decimal. Then in denominator, how many digits are there after decimal? There is only one digit, so there will be only one digit in the denominator. How many digits are under? And those digits will be either 0 or 9. Right? Denominator digits will be either 0 or 9. See, just to understand, if it was only 0.6, then 6 in the numerator, and there is only one digit after decimal, so 0 will be there. Only one digit and without bar. So without bar will give us a 0. Now 0 alone cannot stand there, so 1. So 6 by 10. This is how we can derive it. For example, if it is 0.23, it is 23 upon 2 zeros, and to control 0 we put 1 in the front. That's it. If it is 0.6 bar, it will be 6 divided by. Now everything under bar will give us a 9 in denominator, and for 9 we don't need anything else. So it is just 6 by 9, that is 2 by 3. And the square of, because we have to take square of this number, so square of this number will be 2 by 3 square, which is 4 by 9, and 4 by 9 will be 0.444 and so on. Okay. So it is just 0.4 bar. Okay. So the third one is the answer. Now just to explain this concept further, if it is 0.23 bar, it will be 23 upon 99, right? If it is 0.547 and the entire thing bar, it will be straight away 547 upon 999, right? So those many nines, as many digits are there under bar after decimal. Okay, let's take up the next question now. Question says, how many integers between 400 and 900 are exactly divisible by 2, 3 and 7? Now the numbers that are divisible by all of them should be LCM. So LCM of 2, 3, 7 will be equal to their co-prime. They're nothing common. So 2, 3 are 6, 7 are 42. So basically we have to count multiples of 42 between 400 and 900. Right? 400 and 900. How should we go about it? For this you need to understand this theory. From 1 to 900. How many multiples of 42 are there? Now whenever this is a situation, just take up the last number. Just remember, condition is the set should start from 1. So from 1 to 900, multiples of 42, number of multiples of 42 will be last number divided by 42. So whatever is the last number, divide by whichever numbers of which we want to get the multiples of. So 900 by 42, simplify it carefully. So 6 cancels 900, 150, and 6 cancels 42 7 times. Approximately, take the integer value only, it will be 21. So there are only 21 multiples of 42 from 1 to 900. Similarly, from 1 to 400. 1 to 400, how many multiples of 42 are there? So it will be 400 divided by 42. So this comes out to be approximately equal to, in fact it is 21 point something. So we have to take 21 only. This one comes out to be 9 point something. So we have to take 9 only. Right? Now you see, look at the number line. So from 1 to 400 and to 900. So from 1 to 400 we have 9 numbers. From 1 to 900 we have 21 numbers. So I think by common sense you can make that from 400 to 900 how many numbers will be there? Very clearly 21 minus 9, that is 12. So there are 12 multiples of 42. So there are 12 numbers which are divisible by all of these 2, 3, 7 between 400 and 900. That is option 3 is the correct answer. Okay, let's take up the next question now. Next question says if 3 numbers are in the ratio 3:4:5 and the LCM is 480, find the sum of these 3 numbers. So if I take smallest common multiple as x, then and ratio is given, so we can take the numbers as 3x, 4x and 5x, right? And if you take x common, you will get 3, 4, 5 out. So the LCM will be clearly x into 3 into 4 into 5. And that number is given 480. LCM is given 480. So 480 equal to 3, 4, 12, 5 is 60. So 60x. So x has to be 8. Right? So the sum of 3 numbers will be 3x plus 4x plus 5x. 3x plus 4x plus 5x, that is 12x. You can actually find all the numbers. So it is 12 into 8, which is equal to 96. Okay. So first option is the correct one. Right? So very simple, very easy question. Now the next question. If the number of positive integers which are co-prime to 249, 247, numbers which are co-prime. Alright, what is the definition of co-prime? If there are 2 numbers A and B, if their HCF is equal to 1, that means there is no common factor. That means they are co-prime. That means A and B are co-prime. Now, for any number, there will be infinite number of co-prime numbers. Right? So here it's not saying whether it is below this or above this. We are simply saying there is a number 349247 or for that matter any number. Right? Very clearly there will be a lot of numbers below this, there will be a lot of number above this which will have no common factor with this number. So infinite without getting into any details. Alright, let's go to the next question now. Now this question, it says if the least positive integer divisible by 2 square 3 5, 3 5 square 7 and 5 7 11 square. Now least number divisible by will be LCM. So first let me calculate LCM. So LCM would be common factors 1. So 2 and in fact 3 and 5 are common, so 3 and 5, in fact only 5 is common and all the others ones. Common factor ones and all the others ones, so 2, 3, 5, 7, 11 and higher power because we are taking LCM, so higher power. So 2 square, 3, 3, 1 power, 5, just look at this carefully, 5, 5, 5 square, so 5 square, 7, 7 only 1 power and 11 square, so 11 square. This is the LCM of this number. This is the number which is divisible by all the 3. Now, this number has x distinct prime factors. Oh, right. So this LCM has distinct, how many prime factors are there? Counted. So 1, 2, 3, 4, 5. So there are 5 common factors, 5 prime factors of this number. Second option is the correct one. Just read the question carefully. The question will be very, very easy. Right. The next question. Find the least number which when divided by 12, 18, 33 leaves a remainder 5 in each case. This is the situation of same remainder. Now whenever the remainder is same, what do? First you take LCM of the numbers, so 12, 18, 33 and you simply add the remainder. That's it. This is what you have to do. Okay. This is the standard method. Whenever there is same remainder situation, take LCM and add. Sometimes you will have to take multiple of that LCM. In this question you don't have to because it is simply the least number. So LCM of 12, 18, 33 you can calculate 12, 18, 33. What about the LCM? Let's take 2 common. No, let's take 3 common. So 4s are and 6s are and 11s are. Now 4 and 6 again we have 2 common. So 2, 3, 11. Nothing else common. 3 into 2, 6. 2 into 3, 6 is 36 into 11, 396. So the smallest number will be 396 plus the remainder 5 which is 401. Right? So very simple standard question. Fourth option is the correct one. Okay. Let's take up the next question now. Find the smallest and the largest 4-digit numbers which when lessened by 12 are exactly divisible by 16, 24 and 40. We need smallest and largest 4-digit numbers which are lessened, right? So which when they are subtracted. Okay. So first let's take LCM because we need the number which is divisible by 16, 24 and 40. So LCM of 16, 24 and 40. That comes out to be 120, 240. 240. You can calculate LCM on your own. So any multiple of 240 will definitely be divisible by this. Now here we want a number which should be subtracted 12. So that means any multiple of 240 plus 12 will be our number. Because when we subtract 12, we'll get a number that is divisible by 240. Right? So 240k plus 12. Right? So look at the options first of all. Look at the number, like 1208 is 1200 plus 8. 1200 is divisible by 240. So instead of 8, it should have been 12. So first option is wrong. Right? Second option, 1200 is divisible by 240. There is no scope of 12. So this is also wrong. Perfect. So these two options are anyways eliminated. Next one, 12, right. This seems to be right because it is 1200 plus 12. And 1200 is a multiple of 240. What about 9852? Let's see. If you subtract 12, you will get 9840. Is it divisible by 240, 24, 960? Yes, this is divisible. So this is the correct answer. Right? 1188 is 1200 minus 12. Oh, so this does not fit our criteria. So this is anyways wrong. Okay. So third option is the correct one. Now the next question, it says find the smallest number that must be added to 1994. Alright. Such that the remainder of 28 is left when the number is divided by 38 and 57. So first let's take LCM. LCM of 38 and 57 will be 114. Now what is the question asking? The question is saying 1994, in this we have to add a number, let's say x. This 1994 plus x should be such a number that when we divide it by 114, we get some multiple of 114 and the remainder of 28. That is the question saying. Here you have to be a little careful. Okay. So let's send 28 to the other side. If you subtract 1994 minus 28, it will give us 1966. Right. And plus x should be equal to 114k. Now how to solve? Find out a multiple of 114 which is slightly above 1966 and closest. Right. So if you randomly check this is 11 and this is 19. So let's take randomly 18 times. Right. So 114 into 18. If you take that, what will happen? 18 4 is 72. Then 7. 18 1s are 18 and 7 25. So 5 2 carry. 18 1s are 18 and 2 2052. Perfect. So this is in place of 114k, take a multiple of 114, that is 2052. So 1966 plus x is equal to 2052. Okay, so what is the value of x? The value of x will be 2052 minus 1966. I'll just write it again, 1966. That comes out to be 52 and 34, that is 86. So the required value is 86, that is third option. This is a really tricky question, right? Just be careful, repeat if you need to. Okay, let's go to the next question now. 18th one, find the greatest number which divides 3300 and 3640, leaving respective remainders of 23 and 24. Find the greatest number. Now we are looking for divisor. Divisor means HCF. Right? When we have to find divisible, that means LCM. Here we have to find divisor. So we want which divides 3300 and 3640, leaves remainder 23. So what number will be divisible completely? Right? 3300 is equal to that divisor into some quotient plus remainder 23. Similarly, 3640 is again equal to that divisor into some another quotient plus remainder 24. We have to find the smallest, we have to find the greatest value of this D. I'm just trying to explain the question here. Now what do you get from the first one? You get D into Q1 equal to 3300 minus 23 will be 77. So 3277. And from the second one you get D into Q2 will be equal to 3640 minus 24. So 16. So it is 3616. Alright. Now we need a number that is a factor of both of these two, a divisor of both of these two. So what we'll do, we'll use long division method for finding the HCF in this case. Remember we have to find so our answer of the question will be HCF of 3277 and 3616. I've explained here why. Okay. So 3277 divide 3616 by 3277 goes one time. So 3277 subtracted. And after subtraction, 16 minus 7 is 9, 10 minus 7 is 3, 5 minus 2 is 3. So 339, again divide by 3277, right? So this comes out to be 10 times, 9 times, 9 nines are is 81, 9 threes are is 27 and 8, 35, 3, 9 threes are 27 and 3 is 30. So it is 3051. Subtract this. You will get 7 minus 1 is 6, 7 minus 5 is 2 and 32 and 30 is 2, 2 to 6. Now 339, so this one will come forward I'm sure you are aware about this long division method. In one of the other sessions, I'll explain the long division method of finding HCF. Okay, now 2 to 6 once again. So 2 to 6 subtracted, it comes out to be 113, and 113 divides 2 to 6 completely 2 times. Okay, so here we have HCF as the last divisor, that is 113. So 113 is our answer. Look at the options. Second option is the correct one. This is again a very tricky question and a direct question. Understand the methods and memorize these processes. Okay, let's take up the next question now. Now the next question says, find the greatest number which when divided by 68, 140, 248 leaves the same remainder, right? Directly what you can do in these questions is that take difference of first and second. Difference of first and second will be 32 and 40, 72. Second and third, that will be 140 and 248, difference will be 108, right? Your answer can be achieved from this only, but take the difference of other two also. No, you have to take the difference of other two also. 68 and 248, the difference will be 24 minus 6 is 180. Right? Now, your answer is straight away equal to the HCF of paired differences. We have already calculated the paired differences. Okay, in such question, just remember the language. In such question, directly answer is equal to HCF of paired differences. Right? That is where the importance of my theory video lectures comes here. Right? So, HCF of 72, 108 and 180. You can calculate, it is coming out to be 36. Because 36, 2 times 72, 3 times 108 and 5 times 180. So 36 is that greatest divisor. Alright. Okay. Now the next question now. Now the next question, it says, what is the remainder when 3 to the power 21684 is divided by 5? Now this is standard question. First of all, 3 to the power 21684. Find the power of 3. So 3 raised to the power 1 is 3. I'll just write in couple of powers of 3. That 3 square is 9. 3 cube is 27. 3 to the power 4 is 81. And so on. Find that power of 3 which when divided by 5 gives a remainder of either 1 or minus 1. Right? So here you see 3 divided by 5 remainder is 3. 9 divided by 5 remainder is 1. No, minus 1. Right? Because 5 2 is 10. 27 divided by 5 remainder is 2. 81 divided by 5 remainder is 1. So either 3 square will be helpful to us and 3 raised to 4 will be helpful to us. Let's use 3 raised to 4 first. So if I convert this number as 3 raised to 4, it is very easy to do because 21684 it has to be divided by 4 and it will be divisible by 4. So 3 raised to 4 whole to the power, it comes out to be 5421. Now 3 raised to 4 is 81, divide this by 5. For this 3 raised to 4 you will get remainder 1 and whatever is the power does not matter, 1 raised to the power anything, it is equal to 1. So the answer to this question is 1, that is second option. Right? Now, if I had used 3 square, then how do we go about it? Let's see. 3 raised to the power 21684. In this case, we are getting, let's say, 3 square to the power. Here we will have 10842. Now, 3 squared, when you divide it by 5, the remainder will be minus 1 and to the power. Now, for minus 1, we need to know the power. Why? Because if the power is even, then the value will become positive 1. And if the power is odd, it will become negative 1. So here it is even number, so the value is 1, remainder is 1. That is second option. So this is how you could have used 3 square or 3 raised to power both to find the answer of this question. Let's go to the next one now. Which of the following sets of numbers are relative prime? Relative prime means co-prime. Co-prime means HCF equal to 1. So look at the options. 51 and 1233. Now the simplest way would be, check 51, it is 3 into 17. And 1233 is divisible by 3, so they are not relative prime. Okay. Similarly, 67 is just 1 into 67. There is no other factor as a prime number. Now 567 is divisible by 3. Right. So divisible by 3. So if it is 3 into 567 is divisible by 9 actually. So if I divide by 9, you will get 9, 6 is 54 and 27, 63. So 9 into 63. Right. So they are relatively prime. Now 47 into 423. Let's see. 47 is a prime number, 4 plus 2 plus 3, 4, 2, 6 plus 3, 9. So it is 9 into 4 is 36, 63, 7. Right. So 47 is common. So it is not relative prime. 539 and 481. Right. So here I'll use long division method for HCF 481 and 539 because you may not remember these numbers directly as a part of any table. So once 481. So 9 minus 1 is 8. 13 minus 8 is 5. Alright, now 58 and 481, let's see how it goes. 58, that is 60, 6 times, 8 times. So 8 8s are 64. 8 8s are 64. So 6 and 8 5s are 40 and 6, 46. So 464. 1 minus 4 is 7 and 7 minus 6 is 1, 17. Now 17 does not divide 58, right? So HCF would be 1. HCF here would be 1. So they are also relatively prime. So B option and D option. So look at the options finally here, B and D. Fourth option, B and D are relative prime. Okay, let's go to the next question now. Now the next question, it says the LCM and product of two numbers is 3456 and 13824 respectively. Find their HCF. Right. This is a direct question. If there are two numbers A and B and their LCM is L and H, then there is a direct rule which says the product of numbers is equal to product of LCM and HCF. That's it. This is the only thing that you need to apply. Here the product of numbers is already given, that is 13824. LCM is already given, that is 3456. So the required HCF will be equal to 13824 divided by 3456. Now you have to divide it carefully, right? If you see, we know that it is definitely going to be divisible because the options are integers, right? You just need to check 34 and 138. This is 4 times. This is almost 4 times, right? 4 times. So it is straight away cancel 4 times. You can check it also. 4 6 is 24. 2 carry 4. 4 5 is 20, 22. So 2 here. 4 4 is 16 and 2 18. So 8. And then 1. 4 3 is 12 and 13. So 4 on division it gives us 4. So the required HCF is 4. That is the first option. But you needed to know this rule that the product of the numbers is equal to product of LCM and HCF. Okay. Let's take up the next question now. The next question says 5 people, Archana, Bhim, Chandu, Deepika and Evita, basically A, B, C, D, E, visit a temple at intervals 1, 2, 3, 4, 5 days respectively. If they all together visit the temple today, then after how many days will they visit the temple on the same day? Right, so simply LCM. LCM of 1, 2, 3, 4, 5. The repetition will happen when everybody comes as per their interval. There is no 6. As per their interval. So LCM, let's say for example, Archana will come at a multiple of 1. Bhim will come after multiples of 2 days. Chandu will come after multiples of 3 days. Deepika will come after multiples of 4 days. Evita will come after multiples of 5 days. So when it is a multiple of all of them, that means LCM, they will come together again. So LCM of 1, 2, 3, 4, 5, you can calculate. If 2 is there, if 4 is there, 2 is not required. So 3, 4, 5 LCM will be 12 into 5, 60. That means after 60 days, they will be together again. Straightforward question of LCM. Just try and understand this language. Right? If this is the language, LCM has to be the answer straight away. Next question. The product of two numbers whose HCF is 18 is 5832. How many pairs of numbers satisfy the above condition? Now here it's not asking the LCM, right? It is a different question. How many pairs are possible? Now remember, if HCF is H, then in theory we have done that the numbers can be taken as HX, H into X and H into Y, right? Here HCF is given 18. So the numbers can be taken as 18X and 18Y, okay? And the product is given. So 18x into 18y is equal to 5832. Incidentally, not incidentally, 5832 is 18 cube. So we have x into y, this is 18 square and this is 18 cube. So we get x into y equal to 18. And just understand that 18 is the highest common factor. So there should not be anything common between x and y. Remember, 18 is the highest common factor between the numbers. So x and y should not have any common factor, right? So the possibilities are 1 into 18, 2 into 9, that's it. 3 into 6 is another possibility of factorization, but this is not the correct situation because 3 is common factor between them. So there are only 2 possible pairs of x and y, hence there are only 2 possible pairs of numbers, right? So the options, second option will be the correct answer. Okay, let's take up the next question now. It says find the number of factors of 1728, right? This is a straightforward question. There is a direct formula that we have done. First of all, factorize 1728. Again, 1728 is 12 cube, right? So it is 2 square into 3 whole cube. So it comes out to be 2 raised to the power 6 into 3 to the power 3. We have factorized it into its prime factors. Number of factors is straight away calculated as add 1 to all the powers. So 6 plus 1 and 3 plus 1 and multiply them. So it is 6 plus 1, 7, 3 plus 1, 4, which is 6, 7 into 4 is 28 factors, right? This is a standard formula for number of factors. Factorize into prime factors, take all the powers, add 1 to all the powers and multiply them. You will get your number of factors, right? Let's take up the next question. Now the next question, how many ways 2744 can be resolved as a product of two factors? Standard language, right? The answer of this question is straight away equal to half of number of factors. That's it. Nothing else has to be done, right? Now 2744, if you factorize, it is 14 cube. You should remember these things. 14 cube is 2 cube into 7 cube. So the number of factors will be half into. Now the number of factors will be 3 plus 1 into 4 plus 1. Into 3 plus 1 only, sorry. Into 3 plus 1. So 3 plus 1 into 3 plus 1 is 4 into 4 is 16. Half of 16, that is equal to. So 16 is the number of factors. Half of 16 is 8. So there are 8 such pairs which are possible in this case. Right? Fourth option is the correct answer. Alright, you need to know all these rules. You know, in how many ways a number can be presented as a product of two numbers, straight away it is half of number of factors. And how do we calculate number of factors? That we have already explained in the previous question. Okay, let's take up the next one. A number when successively divided by 4 and 5 leaves respective remainders of 2 and 1. What is the remainder if the number is divided by 5? Now here, we know that when a number is divided by a divisor, we get some quotient and we get a remainder. Here in the first case, in the beginning, our number is divided by a divisor of 4 and we get some quotient, let's call it Q1, plus the remainder 2. Now, what is the meaning of successive remainder? Successive means now that this new divisor, this new quotient that we have got, Q1, this has to be divided by 5. Right? This has to be divided by 5. So if I divide it by 5, we'll get another quotient, let's say Q2. And in that case, we are getting remainder 1. So our original number n can be written as 4 into, in place of Q1, we can take 5 into Q2 plus 1 plus 2. So if you open it, it will be 4 into 5, 20 Q2 plus 4 plus 2. So our number is actually 20 Q2 plus 6. Alright. Now the question is saying what is the remainder when the number is divided by 5? So this is our number 20 Q2 plus 6. Now 20 Q2 is divisible by 5 because 20 is divisible by 5. So the remainder will come only from 6. So 6 by 5, remainder is 1. Quotient is also 1 but we need remainder. So remainder is 1, that is fourth option is the correct one. Okay, let's go to the next question now. Now 28th question. This is a very interesting one, very important question also. For what values of n the following statements are true where n is a natural number? Right? A, 5 raised to n plus 4 raised to n is divisible by 9. Alright. Here it says, now this 9 is actually 5 plus 4. Right. If you remember a very simple rule that a raised to n plus b raised to n is divisible by a plus b for all odd values of n. For all odd values of n. If you just remember that, then this question is direct. Right. Odd values of n, third option is the correct one. Otherwise, you will have to put the values. If I put n equal to 1, then it will be 5 raised to 1 plus 4 raised to 1. That is equal to 9, divisible. Right? If I take n equal to 2, it will be 5 square plus 4 square. Now 5 square is 25, 4 square is 41. Not divisible by 9. So it is not for even, only for odd numbers. But yes, if you remember this, you can directly do it. Now the next one. 18 raised to n minus 2 raised to 4n. First of all, 18 raised to n minus 2 raised to the power 4n can be taken as 2 raised to 4 to the power n. So it is 18 raised to n minus 16. 2 raised to 4 is 16 raised to n. Right? Is divisible by 34. Let's see. Let's see if it is possible. Now for this there is another rule. A raised to n minus b raised to n. Okay. A raised to n minus b raised to n is always divisible by by a minus b. So clearly this number is divisible by, oh, but here we have to check by 34. Now how do we go about it? Let's see. In this case, if I take n to be an even number, let's say 2k, then what will happen? This will become 18 to the power 2k minus 16 to the power 2k. This can be taken as 18 square to the power k minus 16 square to the power k. Now why am I doing this? Because this number will definitely be divisible by 18 square minus 16 square. Right? And which is divisible by, if you factorize this, it is 18 minus 16 into 18 plus 16. Right? Now 18 minus 16 is 2, 18 plus 16 is 34. Right? So if n is an even number, this number is divisible by 34. right? This number is straight away divisible by 34. So if n is all even values of n, it will be divisible by 34. If it is odd number, it may not be. If it is odd number, then it will definitely not be divisible by 34 in fact, right? But if n is even number, it will be divisible by 34. Okay. Now the next one, it is 7 raised to n plus 3 raised to n is divisible by 4 or not, right? Now here it is 7 and 3 and 4 is actually 7 minus 3. See, there is no rule for a raised to n plus b raised to n and a minus b directly. There is no divisibility test directly. So here we will have to put the values of n. So if I take n equal to 1, 7 raised to 1 plus 3 raised to 1, that comes out to be 10. 10 divided by 4, remainder is 2. It is not divisible. And if I take n equal to 2, 7 raised to 2 plus 3 square, now this is 58. 58 divided by 4, remainder is again 2. Alright, so whether I take n odd number 1 or even number 2, the remainder is always coming out to be constant 2. That means any value of n, this value when divided by 4, remainder will be 2. So we can say here is that it is not divisible ever. So not divisible ever matlab no value. Fourth option is the correct one. Alright. Now the next one in this, it says 3 raised to 3n minus 5 raised to 2n is divisible by 13. Let's check it. 3 raised to 3n minus 5 raised to 2n. First of all, let's write it as 3 cube to the power n minus 5 square to the power n. So this comes out to be 27 to the power n minus 25 to the power n. Now 27 to the power n minus 25 to the power n is definitely divisible by 27 minus 25, that is equal to 2. So it is divisible by 2, but we have to check by 30. Oh, so let's do one thing. If I take n equal to even number, let's say 2k, then what will happen? It will become 27 to the power 2k minus 25 to the power 2k, right? So it gives us 27 square to the power k minus 25 square to the power k, right? This number will definitely be divisible by 27, I am writing here 27 square minus 25 square. If you factorize, this will come out to be 27 minus 25 is 2 and 27 plus 25 is 52. Oh, so if n is even number, this number is divisible by 52 and 52 is divisible by 13, right? So this will be divisible by 13 only for even values of n and it won't happen for odd values. Okay, let's go ahead with the next question now. Now the next question, find the highest power of 3 contained in 120 factorial. Standard procedure, 120 factorial. So you start dividing 120 by the power of which is required to be known. So divide by 3, you get 40. Again 40 divided by 3. Take only the integer part. So 13, 3 is 39. So 13. Again 13 by 3. So go and divide it till the time there is a division possible. So 13 by 3 is 4. 4 by 3 is 1. 1 by 3 is not possible. We will not get integer. So just add whatever quotients you have got till now. So 40 plus 13, 53 plus 4, 57 plus 1, 58. So the highest power of 3 contained in 120 factorial is 58. Right? So 120 factorial, it contains 3 raised to the power 58. That is what it means. This is a standard procedure. Okay, let's go to the next question. A number when divided by a certain divisor leaves a remainder of 12. What is the divisor if a remainder of 9 is left when thrice the same number is divided by the same divisor? Alright, so we have a number n which is divisor d into some quotient plus remainder 12. Alright, what is the divisor? Okay, if this thrice the number 3n is divided by the same divisor, we get some quotient, let's say q2, and we get remainder 9. So let's do one thing, let's leave this second part for a second, right? Start from this one, multiply this by 3 on both the sides. So you will get 3n equal to 3dq plus 36, right? Or I rewrite it again, it will be written as 3n equal to, why am I doing this? Because we have to take thrice the number. So 3n is equal to d into 3q plus, here we must get 9 as the remainder. So if I separate 9 from 36, plus 9 plus 27. Now here I should get a remainder of 9. That means this entire remaining thing should be divisible, right? Divisible by whatever we are dividing by. So our divisor has to be a factor of d into 3q and 27. Alright. Now 27, that means 27, the divisor has to be either 27 or a factor of 27. Then only this part will not give a remainder, right? See, remainder should be only 9. That means the entire other part should give a remainder 0. So the divisor has to be either 27 or a factor of 27. Now what are the factors for 27? 1, 3, 9, 27. But in one of the cases we have already got the remainder as 12. That means our divisor has to be more than 12. Right? So out of all of them, the 27 is the only one which is more than 12. So look at the options. Third option is the correct one. So this is a very important and very tricky question. Okay, let's go to the next question now. A number when successively divided by 6, 5 and 3 leaves respective remainders of 4, 4 and 2. Find the remainder when the same number is divided by 9. Perfect. So the first division is number equal to. First division is divisor is 6, quotient is something, plus remainder is 4. Now this quotient is divided by a new divisor 5. So this can be written as 5 into a new quotient plus remainder 4 again. You know, this remainder, this remainder. Now this quotient, the inner quotient is again divided by a new divisor, that is 3. So 3 into some quotient, let's say q, plus the remainder 2, this one, right? This is our original number. So if you multiply this, you will get n equal to 6 into, now inside 5 into 3q is 15q, plus 5 into 2 is 10, plus 4. Now 10 plus 4 is 14. So we have n and plus 4 outside also. So we have, it is 15q plus 14. So if you multiply again by 6, you will get n equal to 6 into 15 is 90q plus 14 6a is 14 6a is 84 plus 4. So the number n is 90q plus 88. Perfect. Right? Now the question is saying find the remainder when the same number is divided by 9. So if you divide this n by 9, this 90q will be divisible by 9, so no remainder. Remainder will come only from 88. So divide 88 by 9, your required remainder will be 9 9 is 81, so 7 remainder. Okay, so look at the options. Fourth option is the correct one. Okay, let's go to the next question now. What is the smallest natural number with which 9450 should be multiplied to make a product a perfect square? So first of all, you need to know also what is the list number should 9450 be multiplied to make it a perfect cube, right? So first of all, in both the cases, you need to factorize 9450, right? So if you factorize 9450, how can you do that? Let's say if you separate 10, you will get 945, and 10 further is 2 into 5. Okay, 945 if you divide by 9, it will be 105, and then if you divide by 5, it will be 21, which is 3 into 7. So 9450 is, I'll write it again, 10 is 2 into 5, 9 is 3 square, 5 as it is, 21 is 3 into 7. Consolidate the powers. So it is 2 raised to the power 1, 3 raised to the power 3, 5 raised to the power 2, and 7 raised to the power 1. This is the number. Now what should I multiply to this to make a square? Understand that in a square, all the power should be even. Here it is 2 raised to 1, so we need to multiply by a 2. 3 raised to 3, so we need to multiply by a 3, so that it becomes 2 raised to 2 and 3 raised to 4. 5 square, so nothing doing, you don't need to multiply by 5. 7 is to 1, so just multiply by a 7. So to make it a square, you need to multiply by 2 into 3 into 7, and that is equal to 42. Right? Now, how to make this a cube? So for cube, all the power should be either 3 or a multiple of 3. So here we have 2 raised to 1, so multiply by 2 square so that it becomes 2 raised to 3. Into 3 already has power 3, so leave it. 5 square, so multiply by 5 raised to 1 so that it becomes 5 to the power 3. 7 raised to 1 is there, so multiply by 7 square. Right, so it is 20 into 49, that is 980. Right, so 42 to be multiplied to make it a square and 980 to be multiplied to make it a cube. Look at the options. Third option is the correct answer. Okay, let's take up the next question now. Next question, it says find the least natural number by which 5 raised to 3 into 7 square into 13 has to be multiplied to make it a perfect square. Directly we can do that. To make it a square, all the power should be even. 5 raised to 3 means we need to multiply by 5 raised to 1. And 7 square, nothing, we don't have to do anything. 13 is already there, so we just multiply by 1 more 13. So 5 into 13, that is 65. That's it. Look at the options. Third one is the correct answer. Just remember, for square, power should be even. Power should be made equal to even. Okay. And for cube, the power should be made equal to a multiple of 3. Right. Now comes the next question. If x and y are irrational numbers, then x plus y minus xy. Now here, this is a slightly different question. See, if I add two rational numbers, let's say 2 plus 3, this will be a rational number. So rational plus rational will give us a rational number. Whereas if you take irrational numbers, so let's say 2 plus root 3, right, and 2 minus root 3, these are irrational numbers. If I add them, what happens? If I add, we will get 2 plus 2, that is 4, right? But sometimes if I take 2 plus root 3 and 2 minus root 5, okay, this will, after addition, it will be 4 plus root 3 minus root 5. So in this case, we are getting irrational plus irrational, still irrational. In some cases, irrational plus irrational, we are getting rational. So the problem here is that whatever is x, whatever is y, whatever is xy, unless we know it clearly, because it is irrational, we need to know the values. Then only we will be able to tell us which one will be the correct one. If it was rational, then the answer was rational. For rational, there is no confusion. But for irrational, we cannot decide unless we know the number. Hence, cannot be determined. Alright, so remember, irrational are not bounded. Right? The binary operations are irrational. What will be the outcome? We cannot decide without knowing the actual values of those numbers. Alright. So here, this is one of the most interesting, most important exercises that you have done. Right? If there is a need, you go back to those some important questions which I marked earlier. Do them again. Again, numbers is one of the most important areas. So make sure that you have done the theory. Because this chapter is very large also. The questions are very small, but the chapter is very large. The theoretical aspect, there are many theoretical aspects that you need to know very clearly. The questions would be direct, right? If you are comfortable with squares, cubes, numbers, multiplication, tables, some of the questions would be like just a cakewalk, okay? But still make sure that you have done the theory videos. I have uploaded topic wise, like rational numbers, irrational numbers, okay? Then calculations of squares, calculations of cubes, multiplication methods, faster methods like Vedic maths and all. I have also uploaded different parts like factorial related questions. I have uploaded remainder for power situations. I have uploaded questions of unit digit, all of them separately, right? So you can watch them carefully and then you can come back to these exercises again. Okay, so this is the end of this video number 8 in this series of shortcuts and alternate methods. 2 more videos are left, 2 more topics are left. One is average mixtures and alligation, and the last one would be geometry. Alright, so till then, see you, God bless you, take care, and happy learning.